So I want to go over a quick video of completing the square. First, I want to go with a basic equation that only has one variable, in this case, the x's. You have an x squared, you have an x. Clearly, this cannot be factored. You can't come up with two factors of 3. So the first thing you want to do is take what we consider the c term, the term that has no variable in it, and move it to the other side of the equation. Then the idea for completing the square is to turn your left-hand side into a perfect square. So a perfect square means that when you, so for example, x squared plus 6x plus 9 is a perfect square because it's x plus 3, x plus 3, or x plus 3 squared. So that's what makes the trinomial x squared plus 6x plus 9 a perfect square. So what's the relationship? Well, if you take half of 6 is 3, and you square that, you get a 9. So in order for this one to be a perfect square, there had to be a 9 in this position. So let's apply that here. In order for the left-hand side to be a perfect square, we have to take -8, right? Cut it in half and square it. So -8 divided by 2, of course, is -4. -4 squared is 16. So basically what we need to do is just add 16. I can't get my blue term back. There we go. Whoops. Sorry about that. Plus 16. That now makes the left-hand side a perfect square. This one would be a minus, so it would be -4 equals. Now, think about what we just did. We added 16 to the left-hand side. This is an equation that always must remain equal. So you're going to add 16 to the right-hand side. 16, so that now becomes a 19. Because we have this perfect square, x minus 4, x minus 4, x minus 4 squared equals 19, we can then go ahead and take the square root of both sides, which just leaves us with x minus 4. In this case, it's plus and minus square root of 19, which gives me positive 4 plus minus square root of 19 as my answer. So that's just a quick review of the basics of completing the square. So what I want to do now is look at how do we put it in the context of a problem that we're doing in Chapter 9, meaning you have a conic, but it's not in your standard form. So here I have an equation that has more than just an x, and it's got an x and a y. So when I look at this, when you look at your equation that's not in standard form, you should still be able to tell if it's a parabola, hyperbola, or an ellipse. Take a look at your terms that are squared. If there's only an x squared or only a y squared, then you've got a parabola. This one, notice, has an x squared and a y squared, so that leaves you with the ellipse or hyperbola. For it to be an ellipse, both the x term and the y squared term, the x squared term and the y squared term need to be positive. Since one of them is negative, we're going to end up with a hyperbola here. So here's what you want to do when you're dealing with two of them. You take your 4x squared, move your terms around, put your x's together for now, put your y's together, and again, take that c term, or that term that does not have an x or y connected to it, and move it to the other side. Now, this gets a little trickier, obviously, when we're dealing with two terms. So the first thing you want to do before you do any completing is factor out, whoops, that should be a 2 because I factored out a 4. Leave a space. So factor out so that the squared term has a 1 as a coefficient. That means when you're dealing with the y's, you need to factor out a -1. That leaves you with a positive 1 coefficient for y squared, and then it becomes minus 6y, and leave your space. Now this is where it also gets a little tricky, because we're going to go through completing the square. So again, we do what we did in the last problem. You've got to come to that b term, this is considered. It's the coefficient, it's the term that has the non-squared variable. So what's half of 2? Half of 2, so you're going to take 2, you're going to divide by 2, and you're going to square it. So what we are adding is a 1 right there. When we look at the other one, we're going to take -6, we're going to cut it in half, and we're going to square it. So we're adding a 9. But you need to be careful at this point. I'm going to go to a different color here. You didn't add a 1 right here. You added 4 times 1, which means you added a 4. So you have to add a 4 to the right-hand side. In this one, we had -1 times 9. We actually subtracted a 9. So you're going to subtract a 9 from the other side. Okay? So let's go through and clean this up a little bit. So we have, hold on. So we have 4x plus 1 squared minus y minus 3 squared equals, and what's that going to give us? -11, and -9 is -20 plus 4, -16. -16. Okay, so we're not quite in our standard form yet. To get it in standard form, you need this to be a 1. So you're going to go through and divide everything by -16. And what does that give us? So notice this is going to lead you with a negative number. So we'll fix that in a minute. So we have x plus 1 squared. That's -4. Negative over a negative is going to give you a positive. Y minus 3 squared over 16 equals 1. And you just need to flip that around. So it's y minus 3 squared over 16 minus, pull this negative out to the front, x plus 1 squared over 4 equals 1. From there, you can proceed with your hyperbola. So you can tell right away this hyperbola, because the negative is in front of the x term, you're basically, I'm not going to draw the whole thing, but we're looking at a center at -1, +3, with a vertical transverse axis. So your transverse axis is going to be this way, which will mean eventually your hyperbola itself is going to be kind of like this and like that somewhere, depending on where the foci end up. Okay, so hope that helps.